Now today we are going to discuss query processing. That means we can write a same query in different multiple number of ways, but out of them which is the most suitable one, which bears least headache or overhead, according to that the query processing strategy, this particular subject is going to be discussed. That means we can write a query in multiple number of ways, but which is the best one, so that will be decided in this particular category. Now we know that this particular tree, this particular hierarchical diagram indicates that how this particular query processing strategy can be divided considering different issues. So, and the corresponding related diagram and related text is also there. Now, how does a query execute? At first, the query will be made available to the parser. Parser will interpret the query to check whether the query is syntactically correct or not, whether the query is containing any error or not. So parser will take the responsibility to check that one at its end. If parser sanctions the query, that means if the query is syntactically correct, that means if the query does not have any syntax error, that means if the query is grammatically correct, then the query will be made available, output of the parser will be made available to the optimizer. So what is optimizer? Optimizer is nothing but a software module which will optimize a particular query. Optimization of a particular query means to reduce the processing complexity, and then it will consult with the disk manager to access the record portion of the database from the disk. While accessing disk manager, the query optimizer will also and the parser will also consult data dictionary, that is the data about data where it will be contained. So the corresponding, you see, access plans are generated. You look at the text. Parser in a query processor verifies and checks the syntax and the feasibility of the query. Then access plans are generated for the query, transform into relational algebraic expressions. Query modifications is called when the query is based on a certain view, and so on. So read this particular text which will be given, which has been given along with this diagram. So a query during its processing executes or goes through different phases. So it has been shown in the structure of a query processor diagram. So this is the total issue. Now let me discuss the total issue using a certain diagram. Using a certain diagram. How? You see, we concentrate on the database consisting of the following four relations. Let us suppose I am considering a database which is consisting of four relations or four tables. The first one is the student number and student name, and how many tuples it is containing, 40,000. And let the next one is the registration. It is having say 4 lakh number of tuples. And then grade, student number, course number and grade. And next is course, that is the course number, course name and the instructor's name who is actually conducting this particular course. So here you see registration is having 4 lakhs number of tuples, grade is having 6 lakhs number of tuples, and course is having 5,000 number of tuples. So that means in total 40,000 number of distinct students, they have taken admission for 5,000 number of different courses, and thus the registration has got a tuple around 4 lakhs. Okay, now actually here I'll be considering a query. That query has got no direct relationship or does not require the table grade. So we'll be concentrating mainly on three tables, so three relations. So they are student, registration and course. What is the query? List the names of courses higher than com 300. So com 300 is nothing but the course ID. So list the name of the courses higher than com 300 and all students registered in them. That means you are supposed to print the student name and the course name for those courses having got course number greater than com 300. So what is the com 300? So that is the course number or course ID. Okay, so this is the query, and obviously you see this query does not involve the table grade at all. So it involves only the student, to fetch the student name, registration because it only knows, it is nothing but a relationship. It knows that which student has taken admission for which course and the course, and here the course number is there, and in this way the query can be satisfied. Now you see. Now you see here, this is a category number 1. Actually here we will be discussing the query which has been written in 3 different ways, and for each and every category I will be doing the corresponding complexity calculations, and I shall show you that category number 3 is the best one and category number 1 is the worst one. Okay, let me tell you that one here. So category number 1, in SQL, select student name, comma, course name from student, comma, registration, comma, course, where student dot student number is equal to registration dot registration, sorry, registration dot student number, and course dot course number is equal to registration dot course number, and registration dot course number is greater than 300. So in this way, you have written this particular query to make the corresponding feasible tuples as output. Now, you can also write the same in an algebraic expression, relational algebraic expression. How? You see here you are doing Cartesian, sorry, you are doing the Cartesian product, not the Cartesian product, but it is actually theta join between student and registration at first, and then with the resultant table with course, and then the total resultant table. On the total resultant table I'll be executing sigma course number is greater than 300, and then I'll be using pi to get the student name and the course name accordingly. Did you get my point? So look at the screen very carefully. I'll be discussing 3 different categories to write the same query. The category number 1 will be the worst one, having got huge complexity, and category number 3 will be the best one, containing least complexity. So I'll be going through some comparative study today. So you see what you are doing actually here. Student and registration, they'll be connected through theta join on student number, and then course will be connected with that with the course number, and on which we'll be executing our selection, that is course number is greater than 300, on which we'll be executing a pi, that is the student name, comma, course name. In this way the total query will get its shape. Now how? Join student and registration. So we know that if we want to join student and registration, student is containing 40,000 number of tuples and registration is containing 4 lakhs number of tuples. So when the tables are not sorted, then the resultant number of tuples getting handled, getting processed is 40,000 into 4 lakhs. But when they are sorted, it would be 40,000 plus 4 lakhs. Did you get my point? I think no. So let me discuss that one. Why this 40,000 and 4 lakhs sometimes are getting multiplied, sometimes they are getting added up. So let us suppose I am considering the student table, and let us suppose I am considering the registration table. Did you get me? Okay. So let us suppose I am considering that these tuples will be in the sorted format. So we are having roll number 1 and the corresponding student name, other student details, roll number 2, roll number 3. Let me omit these dot coms. So in this way I am having up to roll number 4. In the registration, what I am having? I am having roll number 1 and the corresponding course number. So roll number 1 has taken admissions for multiple number of courses. Then what I am getting? I am getting roll number 2. So 2 has got enrolled for roll number 30, for course number 34, and then 2 has got entered for course number 305. Okay, so in this way I'm making my database ready for you. Then say I'm getting this, I'm getting roll number course ID 10. In this way I'm having this particular tuples. Did you get me? So can you tell me whether they are in the sorted way or not? Yes, they are sorted. So now what is happening? For student roll number 1, I'm getting 1 here. So I'm getting a feasible tuple. Then with 1, I'm getting 1 here. I'm moving this record pointer from here to here, from here to here, from here to here, in this way, and keeping the record pointer here fixed, another record pointer. So for 1, I'm getting a match here. So 1 feasible tuple, another feasible tuple, another feasible tuple. But when 1 and 2 are not matching, then this record pointer will come down, and then I'm getting another feasible matching, then another feasible matching, then another non-feasible matching. Then what would happen? The record pointer will come down. Then I'm getting another feasible matching here, another feasible matching here. In this way, how many times these particular tuples are getting scanned? Once. For how many times these tuples are getting scanned? Once. So let us suppose the student is containing 40,000 number of tuples. Then, and this registration is containing say 4 lakhs number of tuples. So 4 lakh number of tuples. Then how many tuples you are getting in total? 40,000 plus 4 lakhs. But when this registration is not in the shorted way, tuples are not in the shorted way, then for a single roll number I shall have to scan all 4 lakh tuples. For another roll number I shall have to scan all 4 lakh tuples. Then how many tuples you are searching for? 40,000 into 4 lakhs. So that's why when they are shorted, then 40,000 plus 4 lakhs. When they are not shorted, then 40,000 into 4 lakhs. Did you get my point? Fine. So now we know that only those students can do the registration whose entry is available in the student table, isn't it? আমি এমন কোনো ছাত্রকে পেতে পারি না যার ডিটেল স্টুডেন্ট টেবিলে নেই, but he has registered for a certain course. So after doing this natural join or theta join operation, how many tuples will be there in the resultant table? 4 lakhs. How many tuples will be there in the resultant table? 4 lakhs, because with each and every registration tuple I'm attaching actually the student details. Did you get me? Did you get me? Okay, now with this 4 lakhs I'm attaching the course. Now I'm doing the natural join, theta join with course. So 5,000 into 4 lakhs, not shorted. 5,000 plus 4 lakhs, so when they are shorted. So you cannot have a course number in the registration which course number is not belonging onto the course table. আমি এমন কোনো কোর্স নাম্বার রেজিস্ট্রেশন টেবিলে পাবো না যেটা কোর্স টেবিলে নেই. So when you are doing the natural join, when you are doing the theta join, then what you are attaching? You are attaching the course details. But how many tuples you will be getting as a result? Again with 4 lakhs. Did you get my point? Fine. Now when you are doing the selection operation, that is sigma course ID is greater than com300. So let us suppose I am getting out of 4 lakhs I am getting 40,000 tuples matching with the criteria. Did you get me? Let us suppose, I am not putting this one that it is mandatory that I will be getting always 40,000 number of tuples, but let us suppose I am getting 40 number of tuples which are matching with the criteria. When you are taking the projection on student name and course name, so you see obviously when you are taking projections you are selecting certain number of attributes, so not reducing the number of tuples in the result. So it will still remain with 40,000 number of tuples as the resultant tuples going for the output display. Greater than বলা কিছু নেই, কোয়েটে তাই ছিল, কম 300 থেকে বেশি কোন কোন কোর্স আইডি ছিল. So let us suppose. So that's why I told you that it is not mandatory that always will be getting 40,000, but let us suppose that 40,000 number of tuples are matching with the criteria given. So in that case, when I'll be applying the projection on it, so that means when I'm selecting the selected number of attributes from this particular selected number of tuples, then obviously the number of tuples are not getting decreased in that process. So I'll be still remaining with 40,000 number of tuples. So did you get me? Fine. So look at the any one of this computation for not shorted or shorted column. You are getting 4 lakhs occurring for 3 number of times, 40,000 it is occurring for twice, and 5,000 is occurring for once. Okay, so obviously you can measure the complexity level. So how many number of tuples are getting formed in between in the intermediate level? It's true that as an output I'll be getting for the all category of problems I'll be getting 40 number of tuples as output, but how many tuples are getting formed in the intermediate level? So that can easily be computed from this computation. So isn't it? So that is 40,000 into 4 lakhs plus 5,000 into 4 lakhs plus 4 lakhs plus 40,000. So this number of tuples are getting formed at different time intervals. Okay, now I'm going to discuss my category number 2. So let us concentrate on the relational algebraic expression. So at first I'm doing the natural join or the theta join between registration and course, and here we'll be selecting the common attribute as the course ID, and on that I'm performing the selection operation where the course ID is greater than com 300. Did you get me? So you are trying to get only the feasible tuples out who are going to contribute on the output tuples. Okay, and then you are doing the natural join or the theta join with the student. The resultant table will be joined with the student, and then you are doing the pi on student name and course name as usual. So now in this particular example, let us do the corresponding computation calculation. So what we are going to do at first, we are trying to do the theta join between the registration and the course. We know that registration was having 4 lakhs number of tuples, and registration and the course is having say 5,000 number of tuples. So need not to explain again and again that when they are not shorted, we are having the computed computation is 5,000 into 4 lakhs, but when they are shorted, we are having the computation complexity like 5,000 plus 4 lakhs. So how many tuples you are getting as a result as output? You are getting only the 4 lakhs number of tuples as output, because you are increasing the number of attributes in the resultant table, not the number of tuples beyond the number of tuples in the registration table. Did you get me? Okay, now I'm going for the next phase. So now when you are doing the selection operation on course number greater than com 300, then from 4 lakhs, how many tuples you are going to select? 40,000 as our assumption. So now when you are doing the natural join and theta join between the student and the resultant table on the student ID, then also you are remaining with sticking with 40,000 number of tuples. Actually here you are attaching student details. Actually here you are attaching student details, so number of attributes are getting increased, but not the number of tuples in the resultant table. Now when you are doing the projection on student name and course name, then obviously the number of tuples are not getting decreased, only the attributes are getting selected selectively. Okay, so we are still remaining with 40,000 number of tuples using the category number 2 strategy 2 query. So now look at under this but not shorted or shorted column. You see 4 lakh is occurring not thrice but twice, 40,000 is occurring not twice but thrice, and 5,000 is occurring again for 5 once only. So obviously to some extent the complexity has been reduced. Did you get me? Fine. Now I am going for the last one. Here let us assume that there are 500 courses whose course number is greater than com 300. So also we have made another assumption that the number of courses greater than the com 300 ID will be the 500 number of such courses are available. So now what we are doing? Why are you going for the natural join at first? Why? At first select only those tuples which will contribute towards the output. So what you are doing? You are doing sigma course ID is greater than com 300. Apply this condition on course, on registration, get the list of tuples who are going to give a contribution to the output, and then do the theta join, and then the resultant table will be theta joined with student on student number, and then do the pi on student name and course name. Did you get me? Why should you consider the total registration table? Why should you consider the total course table? Select only those tuples which will contribute towards the output. So let them be selected at first, and then do the natural join, then do the theta join, and then with that do the theta join on student, and then do the pi on student name and course name. So if we apply, if sigma course ID is greater than com 300 on course, then from 5,000 tuples, how many tuples you are getting as output? 500. Don't go for any kind of argument with me, because it is our assumption. Now from 4 lakhs, how many tuples you are retrieving? From course 40,000, and then you are doing natural join or theta join in between 500 and 40,000. When they are not shorted, multiply them. When they are shorted, add them, and then you are getting 40,000 tuples as output, and do the natural join or theta join with the student table. So 40,000 into 40,000 or 40,000 plus 40,000, but you will be getting 40,000 number of tuples as output. And when you are doing the projection, so obviously I told you that, so there will be no reduction in the corresponding number of tuples. So 40,000 will remain intact. So look at any one of the columns. How many 4 lakhs you are getting? Once. How many 40,000 you are getting? 4 times. How many 5,000 you are getting? and one 500. So you see, complexity has been reduced to a huge extent. The complexity has been reduced to a huge extent. So that's why it is better to use nested queries. So apply selection on registration at first, selection on course at first before going for natural join or theta join. Don't do the natural join or theta join. সর্বনাশ করেছে, not Cartesian product even on the original table contents. So reduce them at first, then go for the ultimate computation. So that is my strategy number 3. In our examination, we may not be getting enough time to write all these 3. In that case, obviously you should write the first one and the last one, because first one will be the worst case and the last one will be the best case. If you don't get enough time, then don't write the SQ query, write the relational algebraic expression only. If you don't get enough time, don't write the grade table, then stick with the registration, courses and the student table only. Okay, did you get me? Fine. Now so this is the total issue which I've discussed here. So query processing, from the query processing we are expecting a question, and also you should know that a same query may be written in different ways. In our fourth chapter number 4, I discussed that intersection could be done in many different ways. I told you that one is exists, another one is in sect membership operator, another one is intersect. So we could do the same using multiple different ways, but which one is most suitable? Using nested queries. Using nested queries. Okay, fine. Okay, now so this is my operator graph. This is my operator graph. What do you mean by the operator graph? Do the natural join between registration and course on course ID. Then in the resultant table, do the natural join between the student and the resultant table on student ID. Then do the sigma on course name is equal to database. Then do the pi on the student name. Did you get me? So this is known as the operator graph. So remember the term, the name of this graph is operator graph. When you will be asked for, please draw the operator graph for strategy 1 or strategy 2 or strategy 3, then obviously you should be drawing the same accordingly. Okay, did you get me? Okay, now let me know for strategy 3 what will be the way to write the operator graph. How at first I'll be using registration, then using sigma, then course using sigma, and then I'll be doing the natural join, and then student with the natural join, then pi. In this way I'll be writing the same. Did you get me, right? Fine. So in this way I'll be writing the same. So it will remain your homework, that write all the operator graphs for all the strategies. It will remain as a homework. Don't miss. Operator graph is this one. Yes, this operator graph which I have discussed right now.
So this operator graph is which one?
For another query. For the another query not related with calculation.
For which query it is?
You can easily write the example. Okay, let me do the reverse one. Okay, let me do the reverse one. Here I will be writing the query for this operator graph. Here I will be writing the query for the operator graph. Will you please help me? Then what you are doing? You are doing registration, and then you are doing natural join. I am writing in this way. Okay, registration natural join on course. Registration natural join on course. Okay, and this natural join will be done on what? On the course number. So this natural join will be done on the course number. Did you get me? And then you are doing natural join on student. So let it put in a bracket. Okay. So now I am writing C hash here. It will help me to write. I am writing C hash here. So allow me to write. Now what should I do? This is my student. Then student, let me know. This is the natural join on student number. On student number. Okay, so now what we are doing? We are getting this one. Then what you are doing? You are doing sigma. Sigma on what?
Course.
There is a course name. Course name is equal to DBMS. You are doing the course name on DBMS. Then what are you doing? Sigma course name is equal to DBMS. You are writing this one, and then what are you writing? You are writing pi on std name on this total. In this way, it was a query on which this particular operator graph has been designed. This is a query. Obviously, I can move from operator graph to the query and query to the operator graph. So that is up to me. So it will remain as a homework. Okay. I have taken this note from Cornelius Pearson edition. From Cornelius. Always try to remember the source book. My note will help you, so that is not an issue. But your book will be your best friend. So now, here is the last one. So you see, at first the query decomposition will take place. That means the query will be divided into several sub-queries, sub-parts, and the query optimization will be done, and then code generation will take place, and the runtime execution, query execution will take place. So this is the compile time, this is the runtime, and total diagram has got a title, that is the phases of query processing. So when the theoretical question will come, we should draw this particular diagram, and the explanation of this diagram has been shown in the note.
Query division means nested query होगा तो नहीं?
नेस्टेड क्वेरी के लिए तो ये चाहिए ना, decomposition, query decomposition for the nested queries. So that's why I should divide the query into multiple subsections, and obviously when the query is becoming nested, then obviously we are requiring this query decomposition. So this is the total issue today. So very important one, try to get it done at your end.